In this video, we'll find second order derivatives of composite functions. Let's do that with an example. Y equals to sine log x. Now this is a composite function. X first talks to log and then log of x, this function then talks to sine. So we're taking sine of log of x and we want the second derivative. We want d square y by dx square. Pause the video, give this a try. Okay, let's solve this together. Let's do this step by step. We'll first find the first derivative, dy by dx. Because this is a composite function, we'll use chain rule. So differentiation of this is first differentiation of sine, that's cos. So sine log of x is cos log of x. And then multiply this with the differentiation of log x, that's going to be 1 by x. So dy by dx is cos of log x upon x. But we want d square y by dx square. So we'll further differentiate. D square y by dx square will be d by dx of cos log x by x. In this case, we have two functions, one in the numerator and the other one in the denominator. And the one that we have in the numerator is a composite function in itself. So d square y by dx square, we'll use u by v, we'll use the quotient rule. So this will be the differentiation. D square y by dx square equals to the denominator squared. So we have x squared. And in the numerator, we have denominator as it is times differentiation of the numerator minus numerator as it is times differentiation of the denominator. Here it's x. So dx by dx is just going to be 1. So this will be the double differentiation or second order differentiation of y equals to sine log x. We have used the quotient rule, but we still have work to do. We need to figure out the differentiation of cos log x. So if you want to do this cleanly, let's take this out. Let's consider this as a different function, z. So z equals to cos log x. We need to find dz by dx. That's going to be d by dx of cos log x. So just like we did for sine log x, we'll use chain rule. This is equal to minus sine of log of x. Differentiation of cos is minus sine. And then multiplying it with the differentiation of log x, that's going to be 1 by x. So now plug this back here. We have d square y by dx square equals to x times 1 by x. So x cancels out. We have minus sine log x minus cos log x. The denominator is x square. So this is the second order derivative of sine log x. Let's solve a similar problem. Let's solve y equals to cos of log of x. Now pause the video, try this on your own. Okay, let's do this together. We'll first find dy by dx. That's again applying the chain rule. We have minus sine of log of x times differentiation of log x, that's 1 by x. Now differentiating again, d square y by dx square, that's d by dx of this thing. This is minus sine log x divided by x. Now here again, we can use the quotient rule. D square y by dx square equals to the denominator squared. And in the numerator, we have the denominator as it is times differentiation of the numerator minus the numerator as it is times differentiation of the denominator. So this is what we have. This becomes d square y by dx square equals to x times differentiation of minus sine log x. Now differentiation of sine log x is cos log x by x. This is something that we already have. So let's use it. X cancels out. We have minus cos log x. And this minus minus is plus. We have plus sine log x divided by x square. So this is the second order derivative of cos of log of x. And now that we have second order derivatives of sine log of x and cos log of x, let's combine both of them and solve a third problem. This is what we have. Y equals to 3 cos log of x plus 4 sine log of x. And we want to prove that x square y2 plus xy1 plus y is equal to 0. y1 and y2 are first and second derivatives of y with respect to x. So pause the video, try this on your own. There are multiple ways to do this. Try to do this as cleanly as possible. Okay, let's do this together. We'll first find y1. That's going to be the first derivative, 3 d by dx of cos log x plus 4 d by dx of sine log x. These are things that we have already solved. So y1 equals to cos log x differentiation is minus sin log x by x, and differentiation of sin log x is cos log x by x. So replacing them, we have minus 3 sin log x by x plus 4 cos log x by x. And because we want a relation between x, y, y1 and y2, we'll keep moving things to this side. So taking x LCM and moving it to the other side, we have x y1, that's equal to minus 3 sin log x plus 4 cos log x. All right, we have composite functions here and we have x y1 here. What do we do now? Well, we need y2. So one way would be to find y2 from this equation, or we can further differentiate this equation that we have. Let's try this method. Let's differentiate this latest equation that we have. Differentiating both sides with respect to x, we have d by dx of x y1 equals to d by dx of minus 3 sin log x plus 4 cos log x. All right, what's the differentiation of the left hand side? Here we have two functions x and y1, and we can use product rule. Product rule says differentiate one keeping the other constant and then add it to differentiating the other one keeping the first one constant. So this gives x y2, differentiation of y1 is y2, plus differentiation of x, which is 1, so 1 times y1. So left hand side becomes x y2 plus y1, and what's the right hand side? Minus 3 constant, we have d by dx of sin log x plus 4 constant d by dx of cos log x. And these are things that we have already figured, so we can plug these values. So we have x y2 plus y1 equals to minus 3, differentiation of sin log x is cos log x by x, plus 4, differentiation of cos log x is minus sin log x by x. All right, let's take this x common. We have minus 3 cos log x minus 4 sin log x divided by x. What do we do now? Well, we can take the negative sign common. We have plus 3 plus 4 minus 3 minus 4. Seems like we have the numerator as y, or in this case minus y. So x y2 plus y1 equals to minus of this, and this is exactly equal to y. So we can replace all of this with just y. We have x y2 plus y1 equals to minus of y by x. Now multiplying both sides by x, we have x square y2 plus x y1 equals to minus y. And then taking y to this side, we have x square y2 plus x y1 plus y equals to 0. This is exactly what we have to prove. Hence, we are done.